Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in Exercise 12.1 Fifth Sum. Okay, so the given question is solve the linear programming problem graphically, and here the given question is maximize z equal to 3x plus 2y subject to, and given constraints are totally 4 we have. So using these constraints, we need to determine the common solution space, that is feasible region, we need to identify. If there is no common solution for all the four inequalities, then solution does not exist for the z. Okay, so let's find out common solution in the graph. So what we need to do is we need to convert these inequalities into equation to draw the line to identify the solution for the individually. Okay, so what is the first inequality? X plus 2y less than or equal to 10. No, I am going to consider as a equation. X plus 2y equal to 10. Okay. So now to draw the line of x plus 2y equal to 10, we need minimum 2 points. Minimum 2 points are enough to draw the line. If x takes the 0, the corresponding y value, then 2y equal to 10. 2 ones are 2 5s are. Then y takes the value 5. If y equal to 0, x takes what is completely, the second term becomes 0, x takes 10. Okay, now let's draw the line of x plus 2y equal to 10. Then we can identify the solution space for the x plus 2y less than or equal to 10. Where do we have? We can identify. Okay, and remember one thing, and in every sum actually I am saying that, so x comma y greater than or equal to 0, it means that we always have the solution space in the only in the first quadrant. So I am going to give more space for the first quadrant. If it is a proper graph, accurately we can draw. Here I'm roughly drawing, but I'm trying to make it as a equal spaces between one point to the other point. Okay, so what is the first coordinate point? 0 comma 5. So 0 comma 5 will be this point. This point is 0 comma 5 point, and next coordinate point is 10 comma 0. So we have 10 comma 0 here. Now on connecting these two points, we can able to get the straight line of x plus 2y equal to 10. So this line is what? X plus 2y equal to 10 line. Now after drawing this red line, that is x plus 2y equal to 10 line, the graph is dividing into two portions. So this is let's consider this as the first portion. Okay, above this red line, it's a first portion, and here we have a second portion. Okay, so we need to identify for the given inequality where we have a solution, above the red line or below the red line. We have a solution or not, we have to identify. So for that, what we can do is randomly take any value. Okay, any value from this side, let's take it. Okay, 1 comma 1, 2 comma 2, or 0 comma 0, any point which lies this side, let's take it and substitute it here. So when we substitute x as a 0, y as a 0, no, 0 plus 2 times of 0, what is the answer? 0. Now what is the condition here? Less than or equal to 10. Is that condition is true? Yes, it is true. Then we can conclude that the solution space for this x plus to first inequality, x plus 2y less than or equal to 10, we have this side. So solution lies this side now. Similarly, we need to identify solution space for the second inequality, same process. So we need to consider the given inequality as a equation. So second inequality what? 3x. 3x plus y less than or equal to 15. No, consider as a equation. 3x plus y equal to 15. To draw the line of 3x plus y equal to 15 in a graph, we need minimum 2 points. So if x equal to 0, okay, if x equal to 0, then we can able to get the y value, that is y equal to 15. But I didn't mark till 15 here. Okay, y takes the 15. Now if y equal to 0, then x takes value 3x equal to 15. 3 ones are 3 5 times. So x equal to 5. Now these points we have to mark it in a graph. 0 comma 15. So tentatively I will just mark it roughly here 11, 12, 13, 14, 15. Somewhere here you will get it. So shall I extend it here itself? I'll just extend. Just overlapping, but it's fine. Okay. So our point is going to be here, this 15. Just remember, it's a graph is continuing. This 11, 12, 13 and somewhere 14 and 15. Okay. So 0 comma 15 and 5 comma 0. 5 comma 0 is going to be here. This point is 5 comma 0 and there we have 0 comma 15. This point is 0 comma 15. I'll just write it here. 0 comma 15. So now if we connect these two, okay, if we connect these two, we got the line of 3x plus y, 3x plus y equal to 15. Okay, now this yellow line, okay, this dividing the graph into two portions. One is this side, that is the right side, the other one left side. So we need to identify which side we have a solution. Okay, so randomly let's take any value from this side. 0 comma 0, it's easy to substitute. Let's substitute. So if 0 plus 0 is going to be 0. 0 less than or equal to 15, yes, condition satisfying. So for this second inequality, solution lies this side only. Okay, we have a solution this side to this graph. You can see that the red line and yellow lines are overlapping. Wherever it overlaps, that will be the feasible region. Okay, only in the first quadrant, because the next two inequalities state that first quadrant. Okay, this line is x equal to 0 line, y axis is a x equal to 0 line, x axis is a y equal to 0 line. Both are greater than or equal to 0, means only first quadrant. So our solution space will be, I'll just highlight it. Okay, common solution starts from here only in the first quadrant. So yes, so you can notice that all the four inequalities will share the common solution space, only this particular portion. Okay, this blue shaded part. Okay, so feasible region exists using the for the four inequalities, then solution exists for the given z. Okay, and you can notice it is a closed figure. It is a closed figure, so it is bounded, and corner points wherever two lines meets for the closed figure, that will be the corner point. So 0 comma 0, and this point is 0 comma 5. This point is tentatively like 4 comma 4 or 4 comma 3. If you don't know, means this is the meeting point of the yellow line and red line, so we can solve it and we can get this. Okay, and this one will be like a 5 comma 0. Okay, now for this, to identify the accurate point, what we can do, the yellow line, that is 3x plus y equal to 15, and the next one x plus 2y equal to 15. So what I am going to do is, using elimination method, I am going to find out. First one, x plus 2y equal to 10. Second, 3x plus y equal to 15. So I'll multiply with this 2 so that we can eliminate y first. So 6x plus 2y equal to 30. Now change the sign. On changing the sign, 2y and minus 2 will get cancelled, and here we have minus 5x equal to minus 20. Negative sign cancel. 5 ones are 5 4 times, so x equal to 4. Okay, no doubt in it, x equal to 4. Here also you can see, okay, x equal to 4. And now uh, x value, let's substitute in any one of this equation to get the y value. Let me substitute here. So 3 times of 4 plus y equal to 15. Then 12 plus y equal to 15. Y equal to 15 minus 12, which is 3. Sorry. So which is 3. So y value is 3. Okay. So in case if you can't able to find the accurate, means you can solve it and you can get it. Okay. When we are drawing in a proper graph, no, these type of confusions we will not get. In case if a point lies between 2 points, then whatever that fractional, writing the fractional number or in decimal value, it's difficult for us. That time also you can solve it and get those values. Okay. So now let's name this O, A, B, C. Okay. So feasible region determined by the given constraints. Feasible region determined by the given constraints. Okay. And also it is bounded, right? It is bounded. It is bounded. So corner points are corner points are, what are the corner points we have? Origin, and then 0 comma 5. Yeah, 0 comma 5. A point is 0 comma 5 and B is 4 comma 3 and C is 5 comma 0. Okay, now all these corner points, what we need to do, we need to substitute in the given Z. Z is 3x plus 2y. Zero comma 0, 0 comma 5, 4 comma 3, 5 comma 0. Okay, 0 comma 0, if we substitute, what is the Z value that we are getting? 0. 0 comma 5, if we substitute, what is the value we are getting? 10. 4 comma 3, if we substitute, 3 times of 4 plus 3 times of, sorry, 2 times of 3. Okay, so in place of x as a 4, in place of y as a 3. 3 4s are 12, 3 2s are 6. So which is 18. 5 if we substitute, no, 5 comma 0, 3 5s are 15 plus 2 times of 0. So 15 plus 0, which is 15. Okay. So what they're actually demanding us here in a question? Maximize. Okay. Out of these four results, which is the biggest value? The biggest one is 18. So this will be maximum. So the maximum value of, therefore, maximum value of given z is 18. At what point we are getting? At 4 comma 3. Okay, that's all the solution. Thank you for watching and please do subscribe. Thank you.